So, we are beginning Mod 20 now. We are on 20.1a. Mod 20 is Statistics, so is Mod 21. We will cover those two modules. And Statistics is a completely different ballgame than the other math that we've done. If you look at today's notes, do you see any, like, numbers? There's no numbers anywhere, are there? Then how is it math? Well, you'll see. Okay. A lot of today, let me get my highlighter. A lot of today is vocabulary. Okay? So, our first vocabulary word of the day, and I'm going to highlight the most important ones. Population is our first vocabulary word. What do you think of when you hear the word population? People, a group, right? When I ask for, or when we talk about the population of the United States, it's some number, right? 2.3 billion, or I don't even know, right? Population in this sense does kind of relate to that, but it's basically the entire group you want to know about. So if I want to ask a question of, what hair color do all students at EHS have? Or do most students at EHS have, I should say. What's my population? My population isn't the United States. My population is what? Students of Etiwanda High School, right? So the population is the entire group that you want to know about. That may or may not be a population number that you are familiar with. Okay? And then we have this thing called a census. Have you heard about the census, as it's commonly referred to? I recently got involved in looking through my Ancestry.com stuff, looking to see where my family came from and all that kind of good stuff. As I was doing that, it has you often refer back to the United States Census. Now, the United States Census is something that happens every 10 years on the year. Now, why do they do the United States Census every 10 years? Because it is darn hard to get information from every single body in the United States, right? Not every single person has a mailing address, right? Does that mean they shouldn't be included in the census? No, they're still people. They're still in the United States. Most of them are citizens. So the census is not always an easy thing to do, which is why we have another census coming up probably in 2020. And so probably next year you'll start seeing a lot of commercials encouraging people that when they get census stuff mailed to them in the mailbox that they return it. If people don't have a mailbox or they don't get information or something, there will be volunteers that come around and find people and get the census information so that we can get as accurate as possible information about who is currently in the United States. That happens every 10 years. So, a census is the process of getting data from an entire population. Okay? A census is a process of getting data from an entire population. Once we have a census, we have what are known as parameters. Parameters are numerical data that we get from an entire population as well. Okay? So, some examples of parameters that you could get. You could get a mean. Like you could get an average age or something like that. Another name for mean is average. And when we're talking about the mean of a population, we use this letter. It looks like this. It's like a fancy U. Does anyone know what that letter is? It's called mu. It's another Greek letter. Remember I said the further you go in math, the more Greek you'll learn? Here's some Greek. You might also find out information about something called the standard deviation. And we'll talk more about that in the next several days. That is notated by this fancy little O with a little hat on top, kind of. That is another Greek letter, and that's actually a lowercase sigma. We learned the uppercase sigma last chapter. That's a lowercase sigma. Looks nothing like the uppercase sigma, does it? You could also find information about a median, a mode, and a range. And some of those words should sound familiar to you, even if you don't quite remember exactly what they are. We will talk about them. This data should be true and accurate because it applies to the entire population. Okay, so if I asked what your favorite color is, and let's say my population was everybody in this class. If I asked everyone in this class what their favorite color was, and most people said blue, I could very accurately stand up and say, most people in my second period class say their favorite color is blue. Because I was able to ask everyone in my second period class and come to that conclusion. That's true. You can't dispute it. If I have data to support it, you can't dispute that knowledge. Now, if I only asked 5 people, and 3 of them said that their favorite color is blue, can I say that of the class, their favorite color is blue? Not necessarily. There's a little bit more fuzziness there, because do 5 people really represent the entire class? Well, it could depend on what 5 people. Okay, so sometimes we only are able to get data for part of the population. Why would it be that we would only be able to get data from part of the population? Why could we not take a census? Well, there's a couple reasons. Sometimes there's too many people or too many in your population. Your population isn't always people, so too many in your population. Okay, when they do the census for the United States, if they're really talking about 2.3 billion people or however many people there are, that's a lot of people. That's a lot of paper. That's a lot of copies. That's a lot of postage. That's a lot of people. It's just not reasonable to do that all the time. Okay, in that same line of thinking, it could be too expensive. All that paper and ink and postage, that all costs stuff. It might be too expensive to do a census of the United States any more frequently than every 10 years because of the amount of money it requires. It could be too difficult to access the entire population. It could be too difficult to access the population. That makes me think of when they, like, for example, when they're trying to count the number of mountain lions or something like that that are in the wild. Can they truly access every single mountain lion? That's kind of hard, isn't it? How do you know when you have them all? Right? So that could be a time where they take a sample, what's called a sample, instead of a census. Or they take a survey, I should say. One other reason that a lot of people don't necessarily think about, but is important, is that if you test the entire population, so testing all, or your entire population, would destroy your population. So, for example, I'm going to use ice cream as an example because I like ice cream. There's never a bad time for it. I also like that show, How It's Made. Have you ever seen that? Where they like show the assembly line and how things go. It's kind of cool. So I'm thinking about watching one on ice cream that I saw once a long time ago. And every now and then, as the assembly line goes by, they have their quality control officers that'll pull out one of those containers of ice cream and literally cut it in half to see, are the toppings evenly distributed through it? Is it mixed enough? Are there air bubbles? You know, to make sure that it meets their particular regulations, right? Now, would it make sense for them to do that to every single container of ice cream? Because that would destroy the population and they wouldn't have any left to sell. So in that case, it wouldn't make sense to take a census and test every single one. They would want to pick every few hundred, like every 100th one or every 200th one or something, to make sure that they are continuing to get the same process or the same quality that they need. Okay? So what do you do if you don't have a population, or if a population isn't reasonable to talk about? Then we talk about something called a sample. A sample is a portion of the group used to make inferences about the entire population that you want to know about. For example, if you ever hear a statement such as, high school students today, all they ever do is wear their earbuds and not pay attention in class. And you sit there and go, wait a minute, they never asked me about this. I don't do that all the time. Why? That doesn't apply to me. Well, what's the sample that they got that information from? Did they just ask a small group of people that perhaps were what we call biased? Maybe they're all musicians and listen to music anyways, because musicians tend to listen to music perhaps more than other people. Who knows? Okay, so a sample is a way. We're going to talk a lot about how do you come up with a sample and make sure that you actually do have a sample that would allow you to make a broader generalization like that. If I wanted to know how many students, or do most students walk to school, or do most students take another form of transportation, whether it be driving or bus or whatever, and I asked all the students and said, let's say I couldn't get a hold of everyone in the school, I wouldn't want to just go out and ask all the people that are at Jack in the Box in the morning, because if they're at Jack in the Box in the morning, they're probably walking to school, right? Whereas if I actually asked maybe 5 people in every single first period on campus, that's a more reasonable grouping of people, and that information possibly could be used to generalize to the entire population, because it's not biased to the people that are already in a certain circumstance. So when we have a sample or a smaller group of people, we do not take a census, we take what's called a survey. So a survey is the process of getting data from the chosen sample. The survey is the process of getting data from the chosen sample. Now that could be electronic, it could be an electronic survey, it could be we'll talk about all the different kinds of surveys actually tomorrow. And then the statistic, or statistics, are what we get numerically from the sample. So it's the information we get from the sample. So, examples of that. We could get another standard deviation. Now, up at top, when we were talking about the population, the standard deviation was this symbol right here, right? The lowercase sigma. When we're talking about the standard deviation of a sample, we just use the letter S. That's how you know it's the standard deviation of a sample as opposed to the standard deviation of a population. We also could find the mean from our sample. But how do you know if it's the mean of the sample or a mean of a population? Well, up there it used that letter mu. When we're talking about a sample, we use this thing called X bar. An X with a bar over the top. That means you're talking about a sample. You could also find another median, a mode, and a range. Just like above. And again, we'll talk more about that. The accuracy of this data depends on how accurate or unbiased your sample is. Oops. I can't even spell today, my goodness. Your sample is. So, we'll talk a lot more about bias, but just a little example of bias is if I were to ask everyone in this room who their favorite math teacher is. I have a biased sample if I'm asking my own students. Because since you know very well that I'm the one that turns in your grades at the end of the semester, you are more likely to respond that I am your favorite math teacher rather than responding honestly. Now, we honestly know you would say me, of course, anyways, but that would be a biased sample because of who I'm choosing. Does that make sense? Okay. If I wanted to ask students, do they know where they're going to college? Okay, what would be an example of a biased sample? Someone that's already at a college, or maybe even seniors who are clearly already applying to colleges and starting to get accepted. That might be a more biased because they know their answer already, whereas if you're a freshman, you might not know yet, right? Okay, so for each example, state the population of interest, and then tell me whether it makes more sense to take a census or a survey to get the information. So, number one, what is the average hours of sleep per night for parents of toddlers? Now, I am not asking you to tell me what the average hours of sleep per night for the parents of toddlers is. I'm telling you that's the information I want to find out. So what would my population be? Who am I interested in? Not even just parents, but parents of toddlers. If you're a parent and you've got all high school kids, I don't care about how much sleep you're getting because you're getting a heck of a lot more than I am. Right? So, my population, who am I interested in? Parents of toddlers. Would it make more sense to give a survey or to take a census? A survey, why? Well, first off, how many parents of toddlers are there in the world?
Not all that many.
A lot in the world, right? It doesn't specify the United States. It doesn't specify Rancho Cucamonga. It just says parents of toddlers. So to be able to contact every single parent of a toddler doesn't seem reasonable, right? So a survey is a more appropriate decision for that one. All right, number two, what is the average height for students in this class? Again, I'm not asking you what the average height is. I'm telling you if that was the information I would want to find out, what is the population I'd be interested in? All students? Students in this class is my population. Would it make more sense to take a survey or a census? A census, why? Because it's reasonable. The people that I'm interested in is a reasonable sized group that I have easy access to be able to ask them a question of. Okay? Whenever you can, a census is more accurate. It's just not usually the more reasonable decision. Okay? All right. The last one I really like. How much weight can a climbing rope support? That's the information I'm trying to figure out. What's my population? Climbing ropes. Right? Climbing ropes. So there's your proof that your population doesn't have to always be people. Right? Would I take a survey or a census?
Survey.
Why a survey?
Because it doesn't specify what kind of climbing rope, just a climbing rope.
It doesn't specify which kind, which means what? There's so many of them, it would be hard to figure out. Another thing that a lot of people wouldn't think about with this, but how do you test how much weight a climbing rope could support? You put weight on it until it breaks, right? And once it breaks, then you know its limit. So if you tested every climbing rope, you wouldn't have any more climbing ropes because every single one of them would have been broken. So you would destroy your population. Same idea with the ice cream thing, right? doesn't make sense to do a census in that case. All right, turning the page. 2 more examples here. I want to know the average weekly overtime hours for all U.S. workers. I randomly choose 50 people and find that the average weekly overtime is 45 minutes. I need to identify the population, the parameter, the sample, and the statistic. Easiest thing to start off with is the population. What is the population that I want to find out information about? All U.S. workers. All U.S. workers. That's my population. What's my sample?
50 people.
50 people, and I'm even going to be more specific than that. 50 randomly chosen. Why is it important to say randomly chosen? So it's not biased. Because technically I'm a U.S. worker. I work in the United States, right? If they asked 50 teachers what the overtime is, we don't get overtime. We're paid by salary. So it wouldn't make sense to ask us. So that's why I want to say it's the 50 randomly chosen people for that. All right, so now we have to talk about parameter and statistic. Now, oftentimes, you will have more information about the statistic than you will about the parameter. Statistic always relates to your sample. S goes with S. Sample, statistic. Parameter always relates to your population. P goes with P. So what the statistic is that is the actual numerical data that you got from your survey. So the statistic in this case is 45 minutes of overtime. Because that 45 minutes is the exact data that they got from those 50 people in their sample. Does that make sense? Now, my parameter, I don't think I have an actual number for, so I'm just going to explain what the number would be. My parameter would be the amount of overtime of all U.S. workers. I don't have what that number is, but that's the number that would be representing my parameter. Does that make sense? So my statistic is the information about the sample. The parameter is the corresponding information about the population. Yeah? All right, I want to know what age most EHS students got their first cell phone. I asked my students in my second period class and found out that more students got their first phones at age 14 than any other age. What is my population? What's the bigger group that I'm interested in? EHS students is my population. Okay. What's my sample? My second period class. Next, that's easiest to come up with usually is your statistic. What's my statistic? Age 14. What is my parameter? Age what? Age, age EHS students got their first phone. So this is the age of my sample. The age of all EHS would be my parameter. Make sense, kind of? Okay. Now I want to talk about these two different kinds of data. that you're going to need to know for a textbook assignment later. We haven't had a textbook assignment forever, have we? I think we have one tomorrow. Do you even remember what your textbook looks like? Okay, we have two kinds of data. We have numerical data, which is sometimes known as quantitative, and we have categorical data, which is known as qualitative. Quantitative versus qualitative. I think of quantitative as quantity. It's a number, it's an amount of something. Qualitative is a quality. It's a quality about something. So starting off with numerical data. Numerical data is, shockingly, numbers.
Whoa.
I know, it's amazing. It usually has some kind of unit with it, such as inches, or meters, or days, or pounds, or seconds, or you name it. It usually has some kind of unit with it. It is measurable. It can be easily measured. I'm going to put a star next to this one because this is the number one way I decide whether something is numerical or categorical. Is if it is numerical, the mean, also known as the average, has meaningful or a meaningful result. Has a meaningful result. Okay. If I wanted to know how tall people are in this class, I could ask everyone in this class how tall they are, and then I could find the mean or the average of all that information, couldn't I? And I could make a statement like the average height of a student in this class is 5'8". Maybe 5'3", depending on if it's shorter class. I don't know. But that statement actually means something, doesn't it? That has value to it. The data has usually an obvious order. So again, if I asked everyone's height in here, there would be an order to that data that I would get. Shortest to tallest, right? Least to greatest. There's some kind of an order. Now, you can have discrete numerical data, or you can have continuous numerical data. Does anyone remember what discrete is? We talked about that before. With sequences, we had all discrete stuff. Because remember, you could have a first term and you could have a second term, but you couldn't have a 1.5 term. That didn't make sense. So discrete numerical, you could have examples like shoe size. Because everyone is either a 7, 7.5, 8, 8.5, 9, 9.5. You fit into one of those standardized numbers, right? You could also argue that that's categorical, I guess, if you wanted to. Students per class. I like that example a little bit better because we can't say that the average class size is 34.2 students, right? Because 0.2 students doesn't really make sense. So we would say that's discrete. It has to be a whole number. Yeah. Continuous are things that don't necessarily have to be whole numbers. So for example, your height doesn't have to be a whole number. You could measure it down to the nearest millimeter if you wanted to. You could even go more accurate than that. Doesn't have to be a whole number. Same thing with your foot size along with your shoe size. Your foot size, you could actually measure your foot size with a ruler and get it to the nearest millimeter or something like that. But when it comes to shoe size, you can't have a size 7 3/4 unless you have a specialist. Okay. Inches of rain is another example of a continuous measure. When you look at the meteorologist on the news and they can talk about the inches of rain for various different areas. It never says 1 inch and 2 inches. It says 1.36 inches, or in our case, like 0.48 inches, because we never get over an inch. Okay? All right, so there's our numerical data. We also have categorical data, or qualitative data, because not every survey, or every census for that matter, is asking for numbers. Sometimes a survey could be asking for your favorite color, in which case numbers don't really play a part, do they? Not as much. So categorical data is categories of data. It is usually words, names, oops, N-A-M-E-S. I'm having trouble spelling today. Names, labels. Sometimes it's numbers. But they're numbers with no units. And I'll give you an example of one in just a minute. It is not measurable. I can't measure what your favorite color is. Again, to the mean. The mean has no meaningful result. And data may or may not have an obvious order. Okay. So, some examples. Car color would be categorical data. If I asked everybody if you could buy any car, any color, what color would you buy a car? That's categorical. Whether you like chocolate or not. And really, it could say whether you like anything. You could fill in the blank with any of those, and it's most likely going to be categorical. Whether you like being outside or inside, whether you like the mountains versus the beach, whether you like chocolate or vanilla. Okay? Those are all categorical or qualitative. Here is one that is a number result, but is categorical or qualitative data. Numbers on a jersey. For example, a basketball jersey or a football jersey. If we took all the numbers on the football jerseys for the football team and we averaged those numbers together, in other words, we found the mean, does the average number of the football jersey numbers have a meaningful result or no meaningful result? It means nothing. If I say the average number on a high school football jersey is 52, that doesn't mean anything. Who cares? It doesn't make any sense to be talking like that. Okay? So those ones, even though it is numbers as answers, there's no units to it, and the mean has no meaningful result. Another example like that, house numbers. Does it make sense to take all the house numbers on your street, add them up, and divide by how many houses there are? Nope, doesn't give us any information that's helpful at all. Right? And your favorite, again, it really could be your favorite anything. Your favorite animal, your favorite color, your favorite whatever. She has on here your favorite band. Those would all be categorical or qualitative pieces of data. Okay? Questions? All right. Happy studying.